Guys, we are almost done. This is going to be our last kind of teaching video, and really it's not because today's going to be a review, but I'll get into that. We are in the home stretch. So all my runners out there, you know, the most important part is to finish strong. When you see that finish line, you start your kick. So that's where we are. We got this. I want you all to finish strong. What is left for us to give you a little motivation to hang in there with me? At the end of this week, right, we're starting week 6 right now. At the end of this week on May 13th, you'll have a cumulative quiz, meaning it's going to take pieces kind of from this whole unit. And your average of all of those quizzes is going to make up your EO9 test grade. So when it's all done, you'll see I'm going to put them in IC, equally weighted in the EO9 test area. So you'll see all of those. All of your quizzes have made that up. If you have a missing quiz, you need to talk to me like ASAP so that we can get that made up. Okay. Then week 7 will kind of be your final review, and then it's your final, and that is it. So we really are in the home stretch. So let's take a gander at what we've learned in EO9. Okay, we started with 9.1. We talked about the Pythagorean theorem. We went into special right triangles on your 30, 60, 90 and on your 45, 45, 90. We talked about the tangent ratio, opposite over adjacent. We talked about sine and cosine. And we talked about solving right triangles using inverse tangent and putting all of these pieces together. Okay, so today's going to be a little bit of review / more problems on 9.6 because that's really the culmination and it weaves in everything we've learned. Okay, so the first thing, I have a question for you. It can be very challenging to figure out which trig ratio we should use. And I've noticed that on some of the homeworks and quizzes that students pick the wrong trig ratio to use. So they're like, oh, we're going to use 27, but maybe I use sine, or maybe it's cosine, or maybe it's tangent. I don't know. So I want you to take a minute, maybe pause your video, and decide which trig ratio we should use for each of these to solve for x. And you're going to jot a note on the side. Okay, ready, go. All right, so now let's see how you did. The trick when you're trying to figure this out is to look at the pieces of what you have. In this triangle, the hypotenuse is the long side. We don't have the hypotenuse, so right away I know I'm not going to use sine or cosine, right? Because remember that our little saying is SOHCAHTOA, and I'll write this out here. And it's, whoa, I thought, SOHCAHTOA. So the hypotenuse is only used in sine and cosine. If I don't have the hypotenuse, right away I know I'm not going to use that. So I'm going to use tangent. So I can say that the tangent of 27 is my opposite over adjacent. Okay, and then it's just solving. We're going to multiply by 10. I'll leave it right there. We're just setting this up. Okay, so then the next one, hopefully you got, what is it? If we have our hypotenuse here, we know it's either going to be sine or cosine. Then we have to look at the angle. Which other piece do we have? If we go across, we have another piece. So that's the opposite side. So we're going to use sine. So we're going to use sine of 46 is going to be opposite over hypotenuse. And then we could solve that by doing 8 divided by sine of 46. Lastly, again, we have a hypotenuse, so we know it's either sine or cosine. And if we look at this angle, right next to it is our other sine length. So that's adjacent, okay? Remember that the hypotenuse will never be one of your opposites or your adjacents, okay? The hypotenuse is its own thing. So here we would have cosine of 54 is adjacent over hypotenuse, and then we could solve for that. Okay, awesome. So that's just a little review on how we can pick which one. In the problems we've done before, I've always told you, like, we're working on tangent or we're working on sine and cosine, but now it's all intermixed, so it could get a little confusing. We also learned inverse trig, right? If we had a known measure, or sorry, a known sine or cosine, can we find the angle measure? Here, if we have the sine of some angle is 0.89, all I have to do is the inverse of sine of that number to get my angle. And that you would do in your calculator, and you just say inverse sine of 0.89, and we get that this angle is 62.9 degrees. We can do that even if it's in fraction form. This would be the inverse cosine of 1/3 is going to give me that measure of angle K. So the inverse cosine of 1/3, we get 70.5 degrees. Okay, this should be review, right? Okay, so if we put this all together now and we want to solve this right triangle, there are a few ways to do this. And I know you just had a quiz over this, but extra practice on this stuff I think is really key. So let's put this all together. There are a few things we need to solve for here. What's missing is angle A, angle C, and side AC. So the first thing we can do is Pythagorean theorem to figure out what AC is. So that's what I'm going to do. So this is a review of 9.1, right? So we're going to have 6 squared plus 12 squared is going to give me my x squared, or that side AC. 6 squared is 36. 144 is equal to x squared. That is 180, right? Okay, take the square root, and we get, oops, we get 13.4. So right away, I know that this side length is 13.4. Okay, so now I have all the side lengths. Now I have to figure out those other angle measures. And there are a few ways you could do this, right? Because we have all 3 sides, you could pick which trig function to use. Let's see if we can focus on A first. Sure, let's do tangent, why not? If I say that the tangent of A is opposite over adjacent, so I'm going to look at my A, go across, that's 12, and my adjacent is 6. Well, 12 over 6 is just 2. So to find A, I'm going to take the inverse tangent of 2. So now in your calculator, inverse tangent, and A is then 63.4 degrees. Okay, so we have our side length, we have angle A. The last thing to do for angle B, or sorry, angle C, we can do 2 things. You could set up another trig ratio, or we know that the total adds up to 180. That's what I'm going to do. Okay, so I'm going to do 180 minus 90 minus 63.4, and we get 26.6. So scrolling down, I know that 180 minus 90 is 90. Just want to show out my steps. And then 90 minus 63.4 is equal to 26.6. So I now have, and that's angle C. I now have a completely solved right triangle. I have all the side lengths and all the angles. Okay? All right, so what I want you to do is pause your video and try this one out. I want you to solve for angle N and side length LM and MN. This one is a little different than the previous one, but I want you to try it out and see how you do. Trying to pause my video too. Okay, now that you've thought about it for a second, what is the first thing we should do? I want you to jot a note on the side. What is the first thing we should do here to solve this right triangle? Okay, so hopefully what you wrote was a trig function or some kind of trig ratio. We can't use Pythagorean theorem yet because we don't have two side lengths. We only have one. Okay, but we could figure out another one. Let's say we wanted to find out NM first. We can use this and we can say, well, this is the opposite over the hypotenuse, which is sine. So I can say that the sine of 52 is equal to NM over 3. Okay, so to find NM, I'm going to multiply the sine of 52 by 3 to get NM. So 3 times the sine of 52 is 2.36. So I know that NM is 2.36. So over here we have I'm going to say 4. Just because my handwriting is so good on this, right? Okay, now the next thing, I'm not going to ask you because you could kind of have different answers for this. You could either start solving for the other angle, right? We know that they all have to add up to 180, and we have this 90. So 180 minus 90 is 90. And 90 minus 52 is going to give us our third angle, N. So N is equal to 38 degrees. Okay, so the last piece of the puzzle now is LM. Now you could do this in a few different ways. You could find another trig function, or you could use Pythagorean theorem. I'm going to use another trig function to see what that's like. Okay, all right, so because we want LM, right, and you could choose either one to do, let's do another example where it's going to be in the denominator. So I'm going to use tangent. So let's say we do the tangent of 52. I thought I scrolled. Tangent of 52 is going to be our 2.36, the opposite, over, I'm going to call this y since we already used x. No, we didn't use x. We actually used the letters, right? So this is LM. Is that right? Yes, LM. Okay, so to solve this now, I'm going to multiply by LM times the tangent of 52 is equal to 2.36. And now I can divide each side by the tangent. So LM is going to be 2.36 divided by the tangent of 52. That's a 5. Okay, so when you plug this into your calculator, 2.36 divided by tangent of 52, we get 1.85. And I now have a completely solved right triangle. I know all the side lengths and all the angles. Pretty cool, right? Okay, I have one last problem for you. It's a little bit of a challenge problem. If we have this suspension bridge here, okay, and we know that the height of these beams are 52 feet, and we know the other beams are at an angle of 32 degrees, and this is repeated. We want to know what the distance is across this suspension bridge. Little application problem for you. Okay. How could we go about doing this? What pieces of information do we need to know? Okay. Hopefully you're saying in your brain or to the screen, we need to know this distance right here, because that'll be the same here and here and here and here and here and here. So once we know 1, we can multiply this by 6 to get the total. Well, how do we find this? If we ignore the rest and look just at this triangle, we can use our trig ratio. We can say, well, we've got an angle and we have the opposite side and we want to know the adjacent. So which trig function should we use? Tangent. Very good. Okay, so tangent of 32 is going to equal 52 over x. Okay, so again, multiply each side by x and divide by the tangent. So x is going to be 52 divided by tangent of 32. Okay, so x is going to be, pull out your handy dandy, divided by tangent 32, we get 83.22. All right, now that's just the distance of what I drew in red. So now we need to multiply that by 6. So my total distance, I'm going to call that d, is going to be 6 times the 83.22. So multiply this by 6, and we get 499.3. 499.3 feet. Okay, awesome. That is the distance across that whole bridge. Okay, so there are application problems for this. I know it's always frustrating to say, well, when are we ever going to use this? This is one of those times where you could actually use it. Okay, so a few things, and I think I already announced some of this stuff, but your last quiz will be Wednesday, May 13th. Okay, so remember that's only on Wednesdays. I'm going to put those into IC shortly thereafter. Then we'll review for the final, and then you are done. Okay, so we are in the home stretch, so try not to lose motivation. I know it's really nice out, and it's tempting to like pretend like it's summer, but it's not. So we got this. Definitely check in with me if you have questions, or if you're having trouble, or if you just want to say hi, because I miss all y'all. So, all right, have a good one. Bye.